All right, this is just some exponent rule enrichment. So we're going to go over the rules. We have the product rule, the quotient rule, the zero exponent rule, the power rule, and what to do with negative exponents. Okay. And then on the other side, there is some practice with the answers. So the first rule is the product rule. Product just means to multiply, or the product is what happens, your result when you multiply something. Okay, so when two bases are the same, x and x, you can take the exponents and you can add them together. So x to the power of m times x to the power of n equals x to the power of m plus n. Okay, so here it says write the base, add the exponents. So our base is x, and then we add 3 and 8, right? We write the 2, and then we add 4 and 2. Here, when you're multiplying, you're just multiplying the like terms. So we'll multiply x times, or we'll group up x, we're multiplying everything, of course, but you're combining x and y and y. Okay, so we'll write the base. The base was x, and then we have 2 plus 3. Here, our base is y, and then we have 1 plus 4, right? And then the 2 plus 3 becomes the 5, the 1 plus 4 also becomes the 5, so that's our final answer. Quotient just means to divide, or what happens after you divide. The bases are still the same, so here we added, sorry, I'm going to be out of the frame constantly, very bad at that. Here we added the exponents because we were multiplying. Here we subtract the exponents because we're dividing. Okay, so we keep the base the same. X to the 5th divided by x squared is x to the 3rd. Let me show you why. Well, we know that it's 5 minus 2, right? But that is true. There's a reason. Okay, this is a shortcut for a reason. Let me show you up here. We'll start with the product rule. So x to the 3rd times x to the 8th. The 3rd power means we are multiplying x that many times. So x to the 3rd is the same as x times x times x. There's 3 x's being multiplied times x to the 8th. So I can now draw 8 x's. 4. Right? So that 3 and that 8, we can add them together. And if you were just to add them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we get 11 of them. Okay. So we're combining them. That just means we keep multiplying. Here we're subtracting. So instead of multiplying, we're dividing, right? X to the 5th is 5 x's. 1, 2, 3, 5 on top, 2 on the bottom. Okay, these are like terms, so you can cancel them. Anything at the top of, on the top of a fraction and the bottom of a fraction, you can cancel. Canceling by drawing an X, that's not very good. And then I'll cancel those. So I can cancel 2 on the bottom and 2 on the top because they were common to both the bottom and the top. And what I end up with is 3 x's on top, right? There's nothing on the bottom, so I'll just leave it as a 1. That's x to the 3rd power. So we either subtract the 5 minus 2, or you can write them all out and then just collect whatever is left over. So there was x to x, there were 3 x's on top, nothing on the bottom. Okay, here we have 5 and 3, so I'll do it again. 5 x's up here, 3 x's down here, and then I will cancel. So those cancel, and those cancel. And what I have left is, oh, I'm sorry, they weren't x's, they were 3s. It should be a 3 though. Okay. So same thing with the 3s. 5 3s. 3 3s. They're common to the top and the bottom. They cancel. So there's 2 3s on the top. 3 squared, you can also write as 9. In my math lab, they will ask you to expand it to the whole number. All right, here we have x squared y to the 5th divided by x y to the 3rd. So 2x's times 5y's. And we're doing the same thing. Good. Now what can we cancel? We can cancel 1 of the x's and 3 of the y's. And what I have left is 1x on the top and 2 y's on the top, which simplifies to x times y squared because there's 2 y's. The 0 exponent rule, that means that any base raised to the 0 power is equal to 1. Y to the 0 is 1. It doesn't matter what y is. You don't have to find y. It's okay to call that 1. 6 to the 0 is 1. You can also put that into your calculator. To verify, all of that equals 1 because the power rule means to raise to another power, write the base and multiply the exponents. So 7, you're just distributing that 0 to everything inside the parentheses. Distribute it to the 7, distribute it to the A, distribute it to the B, okay? So that means it's 7, 0, A, 3, 0, B to the negative first, 0. Good. 7 to the 0 we know is 1. 3 times 0 is 0. So that's still times A to the 0. 6, negative 1 times 0 is 0. So I have 1 times A to the 0 times B to the 0, which is 1 times 1 times 1, which is 1. So they're using the power, I use the power rule there to raise a power to another power, write the base and multiply the exponents. So here we added the exponents, here we subtract the exponents. Now we're multiplying the exponents because x to the 3rd is 3x's, right? And then we're taking that and we're raising that to the 2nd power. So that becomes the 3x's twice, which becomes 6x's. We have 3 squared 4 times. How many 3's do I have in all? I have 8 3's in all, or you can say, sorry, 3 to the 8th is 6,561. Good. All right, and another way, right, is to multiply. So 3 to the power of 2 times 4, which is 3 to the 8th, or count them all out. Z to the 5th squared. So I have 5 times 2 is Z to the 10th. Good. Or there's 5 of them 2 times. So I have 10 of them in all. Okay. Expanded power rule is just the distributive, what I did up here. I distributed the 0 to the 7, the A, and the B. X times y to the m power is the same as x to the m power times y to the m power. That should be an m. Good. X divided by y to the power of m is the same as x to the m divided by y to the m. Okay, so we're going to take that 3 and we're going to distribute it. So that becomes 2 to the 3rd times a to the 3rd, which is 2 to the 3rd is 8, a to the 3rd. Give the 2 to the 6, distribute the 2 to the x. So we have 6 squared, x to the 3rd squared. Remember, multiply the exponents. So that's the same as x 3 times 2, which is 6 squared is 36. 3 times 2 is 6. Here we're distributing the 4. So we have x squared to the 4th and y to the 4th would be the first step, is to distribute the 4 to both places. 2 times 4, because we're raising the 2 to the 4, becomes 8. And here it was just y to the 1st, right? So it becomes y to the 4th. So it's x to the 8th over y to the 4th. Here we need to distribute the 3 to the 2 and the x and the 3 and the y. Okay, so 2x to the third, first we split it by the division bar, and then 3y squared to the third. Then we distribute that 3 to the 2 and to the x. So now 2 to the third, x to the third. Here on the bottom, we're going to distribute the 3 to the 3. So it's 3 to the third, and 3 to the y means y squared to the third. 2 to the third becomes 8, and x to the third stays the same. 3 to the third is 27, and then y 2 times 3 is y to the 6th. Good. Negative exponents. If you move anything across the fraction bar, above or below, you change the place on the fraction bar from the numerator to the denominator or from the denominator to the numerator, the sign of the exponent changes, not the sign of the base, the sign of the exponent. So we always want to write our exponents, write our answers with a positive exponent. So if you at the end you have something like this, you want to, what you're imagining is this is a fraction. Anything divided by 1 is itself, right? So there was 3 to the 8th. It's 6, 5, 6, 1. If I divide that by 1, it is itself. 3 divided by 1 is itself. Okay, so anytime you want to turn something into a fraction, you just put it over 1. And I want the exponent to be positive always. So moving it across the fraction bar means I take it and I put it down here. If it's already down here, I take it and I move it up. Okay, so x to the power of negative m is the same as 1 over x to the positive m. 1 over x to the negative m is the same as x over x to the power of m. So if I'm distributing a negative, so here, sorry, I would distribute the negative n, and so it would be x to the negative n over y to the negative n. And then I want it to be positive. If I want it to be positive, I need to move it across the fraction bar. So it's actually yn xn. Okay. So here are some examples for negative exponents. X to the negative third is the same as 1 over x to the positive 3. Here I have to distribute that negative 3. So I have x squared to the negative 3 over y to the negative 3. What they did immediately is they switched them. They moved them across the fraction bar so that they would be positive. Okay, so that's how we got the y is now up here, the x squared is down here, and the 3 is positive. Now we just distribute that 3, y to the third is y to the third, x squared to the third, we multiply the 2 times the 3, and we get x to the 6th. Good. Here, now we're just taking each one, a to the negative 2, I want it to be positive, so I'm going to move it down here. B3, I leave alone because it's already positive. D to the negative 1, I want to move up here. C to the negative 4, I want to move up here. So now B is up here, or sorry, B stays up here, the exponent is turned positive. C, the exponent becomes, instead of negative 4, it's positive 4 because we moved it. D was down here, now it's up here. You can write the 1 or you can leave the 1 out. It's an understood 1. And the a negative 2 had to move down here. Good. Over here, C, don't be confused. So negative x is okay. Just a negative exponent is the problem, okay? Ignore, or sorry, don't worry about this negative 4. This is okay. The only thing that's not okay is a negative exponent, okay? Those two things are different. So we're just going to take that y to the negative 2 because of that negative exponent, and we're gonna move it under the fraction bar, okay? So we keep the negative 4, we keep the x to the 5th, we only move the y to the negative 2nd, make it a positive 2, okay? Here we're not distributing anything, so you can kind of make it all separate. So we have 3 times x to the negative 2 times y times negative 2 times positive x times positive y to the negative 3. Now I'm going to combine like terms, okay? We're multiplying all of these, so I can multiply 3 times -2 becomes, I'm just gonna go down here. 3 times -2 becomes -6, okay? X to the -2 times X, right? What do we do if they're being multiplied? We add the exponents. So -2 plus 1 is a -1. So I'm just going to call that X to the -1. Can you see that? Yeah, it's okay. And then Y, we have a Y to a +1, an understood 1, right? Just like that X is an understood 1. And then Y to the -3. So if we add -3 and +1, we get Y to the -2, right? Now, there's no fraction bar, but I can make one. There's always a 1 under here. The -6 can stay because it has no exponent. This I need to move because it has a negative exponent. This I need to move because it has a negative exponent. So that becomes -6 up here, X to the first power down here, Y to the second power down here. So that they are positive exponents. All right, the last one is G. I'm just going to rewrite it. It was -2x squared y to the -4th, all to the -2. Okay, first thing I'm going to do. Oh, well, it doesn't matter. I would not have done it this way, but they did. So the first thing they did was they moved this down. Okay, so that now becomes -2x squared over y to the +4 to the -2 power. Okay, just like over here, if we flip everything, we can change that negative to a positive. So now I can flip everything, put the y to the 4th up here. It's still a +4 because we're just changing that -2. -2x squared, and now this is a +2. So by flipping it, I changed that exponent from a negative to a positive, right? Because I would have distributed it all and then flipped it anyway. So now I just flipped it, changed it to a positive. Now I can distribute y to the 4 times 2 over -2 to the second power. Don't forget to distribute that. And then x to the second times 2, which is y to the 8th over -2 squared is a +4. And then 2 times 2 is 4. Okay. So -2 squared is a +4 because that was within the parentheses, right? -2 within the parentheses raised to the second power. -3 squared is the same as -3 times itself, which is a +9. Two negatives make a positive. However, if the parentheses do not enclose it, we're just saying it's a -3 times 3, which is a -9, okay? So make sure you see whether or not the exponent applies to exactly the number right next to it. But if there's parentheses, it's everything within the parentheses, okay? So now let's practice. And I might need extra paper, so. All right, 3 times 4 to the 3rd. Here I just take my calculator and I would say, what is 4 to the 3rd? It's 64 times 3, 192, 192. All right, number 2, 4x to the 3rd times 2x to the 3rd. 4 times 2, so I'm just going to take the like terms. 4 times 2 is 8. X, remember the rule for multiplying exponents is just adding them. So that would be 8x to the 6th. Okay. Number 3, x to the 5th times x to the 3rd is x. 5 plus 3, or x to the 8th. 4, so we're still doing the rule of the power rule, multiplication. 2 times 2 are the like terms. 2 times 2 is 4. X, 3 plus 2, so that's 4x to the 5th. 6 to the 5th divided by 6 to the 3rd, So we can say it's 6, 5 minus 3, but that gets confusing down here if the negative number is bigger, right? So that would be 6 to the second. So another way to do it, remember, is just write how many there are. So there are 5 on the top and there are 3 on the bottom. Did I get that right? And then I can cancel 1, 2, 3. I have 2 6s on top. Here I have x to the 4th over x to the 7th. So that means I have x 4 minus 7, which is x to the negative 3rd, right? I can't have a negative exponent, so I need to put it under the invisible fraction bar. So it's 1 over positive x to the 3rd. Another way to do this, if this is slightly confusing or you just don't like it, is, and I'll put it over here. The reason this is true is because we have 4 x's on top and we have 7 on the bottom. I wanted it to be even, but it's not. 1, 2, 3. All right, and then you start canceling them. And you have 3 on the bottom. So you can make it a negative 3 by subtracting and then move that 3 to the bottom, or you can think, how many x's do I have on top? How many x's do I have on bottom? Cancel out what you can and represent what you are left over, what is left over as an exponent, okay? So that is 1 x to the 3rd is our final, 1 over x to the 3rd is our final answer for number 6. Remember, anything raised to the 0 is just 1. We keep the negative. It's not affiliated with the 0, right? We're going to distribute it to the 9 and to the x. 9 to the 0 power is 1. X to the 0 power is 1. But it's a negative, so that's negative 1. Okay? Now the power rule. Y to the power of 4 times 3, because remember, it's 3 groups of y to the 4th. 4 to the 3, I think, is 12. It's kind of late here, but I think that's true. Here, we're going to distribute that 4 to both the x and the y. So we have x squared multiplied by 4, and we just have y to the 1st power multiplied by 4, so that's just 4. So that'd be x to the 8th, y to the 4th. Here, 6. Now you're going to want to look at these separately, okay? Look at the numbers, see if you can simplify the numbers, and then look at your variables, however many variables you have, okay? 6 divided by 2. I'm just going to put that in my calculator, see if I get a number. 6 divided by 2 is 3. Excellent. So my number is 3, okay? It's on top because 6 divided by 2 is 3, okay? It's not 1/3. Or 6, I can divide 6 by 2 and I get 3. I can divide 2 by 2 and I get 1. 3 divided by 1 is still 3, okay? So that's 3, x to the 7th, x to the 4th. So I can say x 7 minus 4 is 3, x to the negative 3rd, right? Which is like that. Or I can say that's 3, and then I have 7 x's. And I have 4 x's on the bottom. Oh, sorry. Sorry, I made a mistake. 7 minus 4 is a positive 3. Told you it was late here. 3 x to the 3rd. So I have 3 x's, 3x to the 3rd. I apologize. Oh, that's frustrating. All right. Again, we have 8 divided by 4. 8 divided by 4 is 2. X to the 5th minus 2 is 2x to the 3rd. My excuse is I was overeager to practice the hard one. That's why I made them harder. But hopefully it also confuse you. All right, here we are going to, how did they do it? Did they distribute or did they combine first? Well, we don't have that example. Okay. Let's distribute the 2 and then we'll combine it with this guy. So I need to start, these are getting a little bit longer. So I'll write it up here. 13 is 2 times c times d to the 4th squared times c d to the 5th. All right. I'm going to distribute that 2. So now it's 2 squared c squared d 4 times 2 times, right? And we're multiplying all of these times c to the 5th times d to the 5th. Okay. So 2 squared is 4, c squared, d to the 8th, right? C to the 5th, d to the 5th. It's the 8th because 2 times 4 is, sorry, 4 times 2 is 8. So now I can combine like terms. This and this becomes c to the 5 plus 2. Sorry, 4 just stays like that. And then d is 8 plus 5. We're adding them because they're not in parentheses, right? We're not raising a power to a power. We're just combining powers. So that is 4c, 5 plus 2 is 7, d, 8 plus 5 is 13. Good. All right, so 13 was 4 c to the 7th, d to the 13. Just make sure I wrote it right. All right, their next one was 14. And it is 2f g to the 4th raised to the 4th power, f g raised to the 6th power. It's not a very good exponent right there. I'm going to distribute that 4. So I have 2 to the 4th times f to the 4th times g to the 4 times 4, remember, times f to the 4th times g, or sorry, f to the 6th, g to the 6th. Good. 2 to the 4th, I'm going to put it into my calculator. It's 16. F to the 4th, g to the 4 times 4, 16. So I'm g to the 16th times f to the 6th times g to the 6th. Now we're just combining like terms. 16 f to the 4th plus f to the 6th is f to the 10th. And then g to the 16th plus 6 is g to the 22nd, right? So that is 16 f to the 10th, g to the 22nd. Good. 15. Again, you can say x to the 5 minus 1, y to the 6 minus 2, and you get x to the 4th, y to the 4th. Here, x 2 minus, that's an understood 1, y 5 minus 4. So it's x, 2 minus 1 is 1, y 5 minus 4 is 1. So you can just call that x, y. There were no negatives, so we didn't move anything across the fraction bar. All right, now we're raising this to the power of 3. You can simplify it first and then raise it to the 3rd power, or you can distribute the 3 and then simplify, whatever you would like to do. I'm going to simplify it first. So 4 divided by 16 is the same as 1/4, right? Because I can divide 4 by 4, I get 1. I can divide 16 by 4, I get 4. 1/4 x to the 5 minus 1. So this was a fraction, but when I'm subtracting, I always leave it on top, okay? So it's 5 minus 1, y 1 minus 4, okay? I need to write this somewhere else. I already have space. So we had 4x to the 5th y over 16x y to the 4th. And we're going to multiply it, take all of that to the 4th power. No, sorry, the 3rd power. Good. All right. And so what I did is I started simplifying it. So 4 over 16 becomes 1 over 4. X, I said 5 minus 1, right, to account for that 5 and that 1. And then y, 1 minus 4, right, to account for that 1 and that 4. You can simplify this as 1/4 x, sorry, the x is, this is all still on the top. 5 minus 1 is 4. 1 minus 4 is -3, right? So now I need to move this one down. So that's 1x to the 4th over 4y to the 3rd. I don't really need that 1 anymore, so it's just x to the 4th over 4y to the 3rd. Sorry, this was all raised to the 3rd power. Forgot about that. Good. So now that is x to the 4 times 3 over 4 to the 3rd power, y to the 3rd times 3. Losing my voice. All right. 4 times 3 is 12. 4 to the 3rd is 64. 3 times 3 is 9. Okay. So that was 17. 18 is similar. 18 is 5x cubed y over 20x y to the 5th to the 4th. Good. So we have 5 and 20. There, I can divide both of them by 5. 5 divided by 5 is 1. 20 divided by 5 is 4, right? Okay. Then I have x. So these all stay on top. X to the 3rd minus 1. Y, that's an understood 1 minus 5. All to the 4th. I'm not going to forget that this time. So we'll leave that as 1, 4. 3 minus 1 is 2. 1 minus 5 is -4. So now I have x squared up here. I'm going to forget that 1. 4. And I'm going to move that y down to the bottom so that the 4 is now a positive. Okay. Now I'm going to distribute that 4. So I have x to the 2 times 4 over 4 to the 4th times y to the 4 times 4. 2 times 4 is 8, so it's x to the 8th. 4 to the 4th is 256. And then 4 times 4 is 16. Okay. Good. So this is x to the 8th over 256 y to the 16th. Good. 9 y to the -7th. I just flip it across the division bar. Y to the 7th. 1 over y to the 7th. 7 to the -2 is the same as 1 over 7 squared. 7 squared is 49, so it's 1 over 49. Good. Here, we're going to take that and we're going to move it up because it's negative. So it's just x to the +5. This is just 2 to the +4, which is the same as 16. Good. You don't need to do anything with that 1. 2 to the 16 is the same as 16 over 1, right? All right, here we have x to the 5th times x to the -1. Remember, we can add those. We can call that x to the 5 plus -1, or 5 minus 1 is x to the 4th. Good. 24 x to the negative 6 is the same as 1 over x to the positive 6. X to the 9th times x to the negative 7th is the same as x to the 9 minus 7, which is x squared. Good. Here we have j to the negative 13 plus 4 plus 6. That's all I have to do. I just add them together. It's okay that it will end up negative. Negative 13 plus 4 plus 6. It leaves me with a negative 3, right? Which is, I'm going to move it across the fraction bar. So that's 1 over j to the positive 3. All right, we're getting there. Here, I'm just going to flip them both, okay? This one needs to be positive. This one needs to be positive. So I'm going to call that x to the 8th over x to the 1st. That, I can either think of it as 27. I can either think of it as 8 x's up here. And 1 down here. And it becomes x to the 7th. Or I can say it's x to the 8 minus 1, which is x to the 7th. Good. 52 divided by 13. Let's just put that in our calculator and see if we get lucky. 52 divided by 13 gives us 4. Excellent. We got lucky. So I'll just put it right here, 28. We have 52 x to the 6th over 13 x to the negative 7th. We already decided that 52 divided by 13 is 4, or 4 over 1, right? So if I divide 52 by 13, I get 4. If I divide 13 by 13, I get 1. 4 over 1 is 4. And then I have x to the 6th minus negative 7. Good. Because when you're dividing, it's a negative. So that is 4x 6 minus a negative 7. 6 minus negative 7 is 13, because it's the same as adding. Okay. Or you can say 52 x to the 6th, 13 x to the negative 7, and you can say, oh, that's a negative exponent. I want to move it across. So that becomes 4, right? Get rid of those. X to the 6th, x to the 7th, because I moved it up. And then I just add those. And it's the same answer. So I could leave them at the bottom and make it a subtraction problem, subtracting the negative, or I could move it to the top and make it an addition problem and add the positive. Either way, I get 6 combined with 7 is 13. So that's 4x to the 13th. 29 says f to the negative 3 times f squared times f to the negative 3. We're just multiplying, so all that is adding. Negative 3 plus 2 plus negative 3. Negative 3 plus 2 is a negative 1. Plus negative 3 is the same as minus 3 is f to the negative 4, right? I can't leave it as negative 4, so I say it's 1 over f to the positive 4. I move it across the fraction bar. So that is 1 over f to the positive 4. Good. Here, it's just like this one. I want to make them positive first, because that's easier. So that's x to the 9th, x to the 4th. 9 minus 4 is 5. Good. All right. 31. 31 says 24 x to the 6th over 12 x to the negative 8. So they turned into a 3. All right. 24 and 12. 24 is 2 12s, right? So I can just change that to 2. X to the 6th That's a negative 8. So I want to move it up here. X to the 6th, x to the 8th, which is 2x to the 6th plus 8, which is 2x to the 14th. Good. 32. 32 is 3x squared y to the negative 3 over 12x to the 6th y to the 3rd. 3 and 12 is the same as 1/4, right? Because if I take 3 and divide it by 3, it's 1. If I take 12 and divide it by 3, it's 4. X squared stays up here. This y, I need to move it. So I've moved that y. 12 becomes a 4. X is still a 6. Y is 3. And then that y is also a 3. So now I have, instead of that 1, I'm just going to call it x squared. On the bottom, I have 4 x to the 6th. Y to the 3 plus 3 is 6. Good. Now, x2 minus 6. Or sorry, over 4y to the 6th. Okay. I don't have that because I'm going to subtract it from this and see what I get. 2 minus 6 is negative 4. I need to move that down because it is a negative. I want it to be positive. So now everything's under the fraction bar. I just put a 1 up here. 4x to the 4th, y to the 6th. Or when you saw it right here, right, we could also call that 2x's over 6x's. And say, oh, 2 of them are going to be canceled and we'll be left with 4 on the bottom and none on the top. So fine way to do it as well. So 32 was 1 over 4 x to the 4th y. Did I write that down there? 1 second. Y to the 6th. I was looking at it and I was trying to check my answer and it is the right answer, but right here there's one that's like almost identical and I was like, oh, did I write it down now? I did not. We're only on 32. We're not on 34 yet. All right. 33 says 2x to the 3rd, y to the negative 3rd to the negative 2 power. Okay. And then I'm just going to distribute that negative 2. So I have 2 to the power of negative 2, x 3 times negative 2, right? That's how I distribute it. Y negative 3 times negative 2. So you can move this down to the bottom, right? But because it's a negative, you might not want to, because a negative times a negative will become a positive, so we didn't need to move that one. So I would distribute, in this case, before I moved this to the bottom, but you would get the right answer either way. 2 to the negative 2 is, sorry, we're just going to call it, I'm going to leave it alone. It's still just 2 to the negative 2. Hex 3 times negative 2 is a negative 6, right? Because a positive times a negative is a negative. Y, negative 3 times negative 2 is a positive 6. Okay. Now I see that I need to move this one, and I need to move this one. What I get is y to the 6th over 2 squared x to the 6th, which is y to the 6th over 2 squared is 4 x to the 6th. Good. All right. 34. So 33 was y to the 6 over 4x to the 6. 34 is 2x to the 4th y to the negative 4 over 8x to the 7th y to the 3rd. First thing I see is I can move this down. 2 and 8, if I divide them both by 2, I get 1 up on top and I get 4 on the bottom, right? X to the 4th, that y is on the bottom, so I have x to the 7th, y to the 3rd, y to the 4th. That becomes x to the 4th on top, 4 x to the 7th, y to the 7th, because 3 plus 4 is also 7. Now I need to call that x 4 minus 7. Very similar to what we've done before. So x to the 4 minus 7 is x to the negative 3 over 4 y to the 7th. So that is 1 over 4 x to the 3rd y to the 7th. I had to move that down because it was a negative. Or you can just look at it and say that's a 4, that's a 7, the difference is 3, and the bigger number's on the bottom, so I'm going to give it 3 on the bottom. So 34 is 1 over 4 x to the 3rd y to the 7th. Good. 35. Is 4x to the 4th, y to the negative 4th, 3. Good. 4 to the 3rd, x to the 4 times 3, y to the negative 4 times 3. Good. 4 to the 3rd is just 4 times 4 times 4, which is 64. 4 times 3 is 12. Negative 4 times positive 3 is a negative 12. Written it twice now. So I would leave that at 64 x to the 12th, but I need to move that y down because it's a negative exponent. So 64 x to the 12th over y to the 12th for 35. $36. I have 5 times x squared times y. So anytime they're next to each other, just means multiply, right? Times 2 times x to the 4th times y to the negative 3rd. So I'm just going to combine like terms. 5 times 2 is 10. X squared times x to the 4th is x to the 2 plus 4. Y to the 1st times y to the negative 3 is 1 minus 3. So I get 10x to the 6th, y to the negative 2, negative 2nd, I should say. So that becomes 10x to the 6th over y to the 2nd. All right, last two. 37 is negative 7a squared b to the 3rd c to the 0 power over 3a to the 3rd b to the 4th c to the 3rd, all raised to the negative 4th power. Okay, remember, if you want to make that negative into a positive, which I might because it's a lot of distributing to do, we flip everything, right? If I don't want, if these are all negative exponents all of a sudden, I'm going to move them over here and they'll be positive. If these are all negative exponents, all of a sudden I'm going to move them up here and they'll be negative. It's even okay if some of these are negative, it will still work. So instead of that being a negative 4, it's now going to be a positive 4. So everything down here, I'm going to put up here. 3a to the third, b to the fourth, c to the third. -7. So the only negative I'm changing is this one. So it's still -7, a squared, b to the third, c to the 0. And now we're just raising it to the regular 4th power. Now you can either simplify or you can distribute the 4. So we could say we'll leave the 3 and we'll leave the -7. A 3 minus 2. Okay. B 4 minus 3. C 3 minus 0 to the 4th. Okay, so the only thing down here is this -7. Good. So now I have 3. A 3 minus 2 is 1. B 4 minus 3 is 1. C 3 minus 0 is 3 over -7. It doesn't matter where the negative is. It could be a -7, it could be a -3, or it could be a negative out in front, just as long as it's there. Oh, and sorry, this was all raised to the 4th. So now I can distribute that 4. So 3 to the 4th, A 1 times 4, B 1 times 4, C 3 times 4, 7 to the 4th, sorry, -7 to the 4th. 3 to the 4th is 81. A to the 4th, B to the 4th, C to the 12th. -7 to the 4th power is -2,401. Good. All right, that's our final answer. And then 38 is our last example. We have -2 a to the third b squared c 0 over 3a squared b to the third c to the 7th raised to the -2 power. Again, I'm going to flip them, make that -2 a +2. So that becomes -2 a to the third b squared c 0, 3a squared b to the third c to the 7th. Now that -2 is a +2, we flipped it so that the negative exponent would become a positive exponent. So now I have 3 -2 a 2 minus 3 b 3 minus 2 c 7 minus 0 all squared. Also, if you don't want to do it this way, you can write out there are 2 a's up here, right? So this would be a times b times b times b times, right? 3 7s. And then this would be a times a times a times b times b. And then you can cross cancel them out, right? So that would be 1a down here, 1b up here, 7 c's up here. So that's 3 -2. 2 minus 3 is -1 a's. 3 minus 2 is 1b. 7 minus 0 is 7 c's, all squared. So that'll be 3 b c to the 7th. I'm going to move that a down here because it's a negative. -2a, right? Since they're ones, I'm just going to leave it as an understood 1. 3 squared b squared c 7 times 2, -2 squared a squared. 3 squared is 9, b squared, c to the 14th, negative 2 squared is a, oh, sorry, it should be in parentheses, right? Negative 2 squared is a 4, and then a squared. So that's our last one. This was 9 b squared c to the 14th over 4a squared. This one was 81 a to the 4th b to the 4th c to the 12th over negative 2 4 0 1. Is that true though? We said negative 7 to the 4th. I guess it should have been in parentheses, so it's positive 7 to the 4th. Sorry. Negative 7 to the 4th is positive. Those parentheses are important. So those are the rules of exponents and maybe any way you might see them.